Okay. All right. Good afternoon. This is WASA Distance Education, MBF3C, grade 11 College Prep Math. I'm Pete, and I'm your teacher. So welcome to our class. This is the last class of our first week. Imagine that. It does go pretty quick, doesn't it? So keep in mind that we only have 4 classes a week, Monday through Thursday. So there's no class Friday. You're welcome to contact me though on Friday if you have any questions, anything you want me to help you with. Okay, and that's pretty much how it works. Now, what we were looking at yesterday, we kind of got started with lesson 2. I'm going to back up a little bit. I'm not going to just reteach the whole thing, but I am going to just back up a little bit in lesson 2, just to make sure that we have a good, solid foundation. This particular topic in chapter 1, algebra, it depends on what you saw before, how you'll find it. And I understand it can be a little bit challenging. So we're trying to get you the best possible start here. Okay, now Unit 2 is I think a little easier, and certainly Unit 4. So it's not all really super tough. Now, one of the things I want to talk about sending in the key questions, I did mention yesterday. I encourage you to send in maybe one set of key questions to start, just so that you get an idea of how I'm marking and how things will go for you. And like you said, don't worry about perfection. Okay, I'm not looking for perfection. What I want to know is, did you learn the material? Do you know how to factor a polynomial? Do you know how to use the distributive property? Can you tell me what a parabola looks like when you see it in vertex form? So that's what I'm looking for. So send in what you got, and I'll tell you how you're doing. And if you want more marks, you can always redo some of it and send it back in. Okay, so don't worry about perfection. Now we're going to just continue our look at the distributive property, and what we're working towards. What we were working towards yesterday was FOIL, okay, and using FOIL to multiply 2 binomials together. So that's two polynomial terms in brackets, and those show up quite a bit actually in algebra. So we did a lot of work here looking at the different parts of a polynomial. I'm remembering that the degree of the polynomial is just the highest exponent in the polynomial. So if 2 is the highest exponent, then it's degree 2. And we usually sort things in order from highest exponent to lowest exponent, and at the same time, if you have more than one variable, in alphabetical order. Okay, and that's just a convention of style. If you forget to do that, then I'll point it out in your assignments, but I'm not going to take any marks off. Now, there are a couple things, though, that aren't really style. There's actually a right and wrong way to do things, so I'm going to kind of talk about that. Yesterday, we got started here with the FOIL, the idea of FOIL to multiply 2 of these binomials together. We're on page 14 here. I gotta remember that my page numbers are on the bottom and you can't see the bottom half. So for support question 1, we went through it, and this was just multiplying a monomial, which is a one term, one term, with a binomial, which is 2 polynomial terms. Now we're going to step things up a little bit with this next example, which is expanding and simplifying binomials. Binomial is just one of these. X minus 3 is a binomial. 2x plus 4 is a binomial. It has 2 polynomial terms in it. Polynomial, constant, like a number, a variable, like x, or a constant and a variable, like 2x. Okay, and then you know that it's a binomial because they're joined together by addition or subtraction. Okay. Now in algebra, just to clarify, and you may already know this, but just to clarify, when we put 2 things together in parentheses like that, what we mean is multiply. So what that example 1 says is 2x plus 4 times x minus 3. And the reason we don't use an x for multiplier, we don't use a multiply symbol, is that um, we use the variable x all the time in algebra. So we've decided then that we're just going to multiply either by putting things together. So if I write 2x, that means 2 times x. Or we can put things in parentheses, right? So that means 2 times negative 2. Now you may ask me, well, Pete, why didn't you put the 2 in parentheses? You know what? Some mathematicians do exactly that. Perfectly valid way of doing it. And that's a style thing. Whether you want to do it that way or not is entirely up to you. Okay, but we do have to separate it somehow. So you're going to need at least one set of parentheses. It's kind of, I think I'd probably do it in a more traditional way that way, which is this, that you put a constant out in front of the brackets. And all that means is this multiplied by whatever's in the brackets. Okay, now we're ready to tackle this problem where we're multiplying a 2x plus 4 times x minus 3. Okay. And what I do is I kind of give you a step-by-step way of doing it. And if you follow that step-by-step way, it's really hard to get into trouble. So we got started yesterday, but you know what? Yesterday was yesterday. Let's just start over again. It's a nice thing about math. You can always start over. Clean slate here. Okay. So where we got yesterday was we almost were done. But let's try again. So we have 2x plus 4. I didn't really want to pick red, but anyway. And we have x minus 3. Now, normally I'd do this all in one line. I'd put an equal sign just next, but I just don't have enough room, so I'm just going to do it down below. I want to leave myself some room because this is going to actually have 4 different terms in it, polynomial terms, before we simplify things. So let's remind ourselves what the FOIL stands for. FOIL stands for front, outside, inside, last. Okay, FOIL. And if you follow the FOIL method of multiplying 2 binomials together, you're always going to get it right. Well, unless you make a math mistake. But which you'll see me do that here too. So it's not a big deal. You know, math mistakes is you know, it's part of the game, right? So so let's try this. Front says 2x times x. So in a case where you just have a constant and variables, you just multiply the variables together. So x times x is just x squared. Okay. So we've done step 1. This is step 1. That's step 1. Step 2 is our O, which is outside. Okay, what does that mean? Outside means that we're going to take the 2x and we're going to multiply it by the outside of the second one, which is negative 3. Now, please keep in mind that when you're doing FOIL, when you're multiplying using the distributive property, which is what we're using, the multiplication includes the signs of both terms. In the case of 2x, we assume that it's positive. There's no plus sign, but we know it's positive because there's not a negative sign. And then negative 3. So the first thing you do is figure out the sign. The first thing, and if you do that, you'll never go wrong with the signs. So we have a positive times a negative, right? Positive 2x times negative 3. Positive times a negative, the signs are different, which means that the answer is going to be negative. That's always the case. Okay? Signs are different, and so the answer is going to be negative. Now we don't have to worry about the sign anymore. Let's just worry about the numbers. What we have is 2x times 3. So we don't have any x's to multiply, so let's do the 2 times 3, which is 6, and then we just put the x down. The x just comes along for the ride. Very identical to the way the 2 came along in the first term, right, where we didn't have anything to multiply it by. Okay. So now we have negative 6x. And we've done the O part of it. So I can call that 2 right there. It's probably going to be hard to see. And so then the next step 3, is inside. So that means we're going to do the two inside terms. I'm going to back up a little bit. I'm going to change to green so that you can see that. So inside. So the two inside terms. That's what that means. Okay. So front, outside, inside. And what FOIL does for us is gives us a way to keep track of what we've already done. Okay. You could do it in some other order, but really FOIL just helps us to do it in a systematic way. So we have plus 4, positive 4 times positive x, right? We know that there's x has to be positive because there's no negative sign in front of it. So a positive times a positive, the signs are the same, which means that the answer is going to be positive. Okay? And okay, just hold that thought and we'll see. So, who do we have from Wiagama? Is that Charlotte?
Yes.
Okay, how's it going, Charlotte?
Good. And I'm listening in through at home.
Okay, all right, perfect. Are you able to see it at all, or?
No.
Okay, so if you just speak up if you have like if I say something and you don't know where we are, just remind me, okay?
Okay.
All right.
Right.
So right now, then we're on page. What page are we on? We're on page 13, and we're just doing an example. Sorry, we're on page 14. What page are we here? I don't know. Oh yeah, we're on page 14. We're sort of on the expanding and simplifying binomials using the distributive law. Okay. So we are using the concept of FOIL, which is a way of keeping track of how to multiply two binomials together. FOIL stands for front, outside, inside, last. Okay, and really, if you put FOIL into a Google search engine or any search engine, Bing, if you like Bing, it'll get you all sorts of stuff on FOIL. Okay, so what we were doing here then, we did the front and we ended up with 2x squared. We did the outside, we ended up with negative 6x, and now we're doing the inside. We're on the I part of it. And the way I tell students to do FOIL is to work out the sign first. You can't go wrong if you work out the sign first. So in this case, the inside is in green, plus 4 and plus x. So a positive times a positive. The signs are the same, so our answer is going to be positive. And I put a little green plus sign there. Okay. Now that we've worked out the sign, we don't have to think about the signs anymore. We just have to look at the numbers and variables. So I have a 4 times x. Well, I don't have another number to multiply it by, and I don't have another variable to multiply x by. So 4 times x is just 4x. Okay, and that's exactly the same. Imagine if instead of x we had a 5. Then it would be 4 times 5. The difference is that we could write 4 times 5, 4 and then the 5 in brackets, but because both of them are numbers, then we could actually work that out and give a number for it. But in our case, we don't know what x is, right? So all we can say is that it's 4 times x. X is something, right? X is a box marked x. We don't know what's in that box, right? We're going to figure that out later. That's the beauty of algebra. It lets us do calculations, mathematical calculations, without having all the numbers. That's really the whole point of algebra. Kind of cool. All right, so we have our inside. We got 4x. And now we're going to do step 4, which is last. And I'm going to change to black. Bring out the black ink for a rare visit. So last means that we're going to do the last terms in both binomials. So I have a plus 4 and a negative 3. And I'm going to keep saying this. The terms, when we're using FOIL, when we're using the distributive property, when we're doing our multiplications, the sign in front of the number or variable is part of the calculation. So we have plus 4 times negative 3. Step 1, work out the signs. So I have a plus times a negative, positive times a negative. The signs are different, which means our answer is going to be, yes, when the signs are different, the answer is going to be negative. Now we don't have to worry about the sign anymore. Next step, going to work out the multiplication. Now we have something we can calculate. 4 times 3. 4 times 3, plug that into your calculator, get 12. Okay? There you go. Okay. So that's the first step in doing our expansion of the two binomials using the distributive property. But there is one more step we have to do. Okay, and this is not really a style thing. This is kind of something you really have to do, and that is we have to do something called combining like terms. Okay, that's what it's called, combining like terms. Now, they're using the word like in a way that maybe we don't use it these days. It doesn't mean you like them. It means they're similar. They're mathematically similar. And what it means, what a like term is, it has the same variable and exponent. Okay, you can't read that. It says exponent. And plus, or it's they're constants. Okay, so numbers. Okay, that's like terms. Now, I know you're going to ask because I talked about some polynomials having more than one variable. A like term has the same set of variables. So if you had a 2xy, you could only combine it with other xy's. Okay. So the variable, if it's one variable, they both have to be the same, have to have the same exponent. And then if it's two variables multiplied together, they have to be the same, and each variable has to have the same exponent as the one you're combining it with, not necessarily the one in the term. Okay. So combine. Now, for anyone that's following this, I said combine, and I don't know what I wrote. Combine? I don't know what's wrong with me. Combine. That's what I meant to write. Okay, so there you go. So now it says combine, sort of. So we got to combine like terms, and what that means is that we're going to go through our polynomial, and we're going to add and subtract stuff that we can add and subtract. So let's put another equal sign down, and now I have 2x squared, and I'm going to look through this thing, the rest of the polynomial equation, polynomial. Yeah. And I don't see any other 2x squareds or any other x squared, so I'm just going to write 2x squared. Obviously, we don't have anything to combine it with. But notice this second bit here. I have a negative 6x and I have a plus 4x. Now, they both have x as the variable, and they both have the same exponent. There is no exponent, but like a lot of things in algebra, if there's no exponent, it's not there. It has an exponent. It's just 1, x to the power 1, right? So so I have a negative 6x plus 4x, and we're going to combine those in exactly the same way you would work numbers, right? If you had negative 6 plus 4, you could plug that into your calculator, right? And you should get negative 2, but it's x, right? We're talking about x's, right? You have negative 6 apples. Someone gives you 4 of them. Now you have negative 2 apples. I don't really know what that looks like, but there it is. And now finally we're going to combine any constant terms, and let's have a look here. I have negative 12, and there is no other constant term, so I'm just going to write that down. So now we have our answer, and our answer is it's 2x squared minus 2x minus 12. Okay, so that's a good example to go through if you're getting kind of stuck, if you're having trouble with these. You can go through that and then check, because they have the answer in the book. Now, you'll notice that in the book they do it slightly differently in that they have at least, I don't know, they have one duplicate step in there, but they have the first step that they do. If that works for you, then go ahead and do that, of course, right? I just skipped to the second step. Okay. All right. Well, let's take a look at the second example then. So this is page 15. Oh, okay, well, okay, now it's page 15. and they say simplify. So simplify, simplify, expand. It's really, they use different words, unfortunately. What it means is do whatever you can to this, right? It's two binomials, and so you're going to have to multiply them together. Okay, there's not much else you can do there. So they're going to show you how to do that, and it would be worth it to try and work it out. Make sure that you especially get the signs right, because that's something where students have some difficulties. But if you work out the signs first, then it should be a little easier for you. All right. Well, here's our support questions. Look at that. Expand and simplify each expression. Okay, so now what they're saying is expand, which means a FOIL. And simplify, it's funny that they have to say that because this is combined like terms. And really, I don't, that there's really no reason to say that. That's what you're supposed to do. You would never leave it with like terms, more than one, like, yeah, you'd never leave it unsimplified like that. All right, well, let's take a look at some of these. There's some really good ones here. Let's try C. C looks really evil here. Now, if you're following along here and you see one from the support questions, which your page, I better say what page it is, the top of page 16, so it's support question 2, or any of those. If you see one in there that you want done, let me know and I'll show you that one. Okay. That's probably the best way. Unfortunately, because of I can't sort of stand in front of the class and kind of see whether you're looking puzzled or not. So if you want to see one, you're going to have to tell me that one of them puzzles you. So I'm going to do C. I'm also going to do F because that's a kind of a cool one. And then we'll do a few of these from question 3 here as well. Okay, so a little bit of extra work to do there. All right. I'm going to make a blank page here. And, whoa. Okay. Now, if you missed the first class, there was one important point that I wanted to mention about when you're handing in the key questions. When you're doing something like this, now this is a support question, but the key questions look exactly the same. When you're handing them in, you don't have to write out the question. Okay. Now, for this, I find it easier to start by writing out the question, but if you don't want to, you really don't have to write out the question. Especially like the word questions and stuff like that, they can be, okay, that was kind of, they can be challenging to, there's a lot of stuff there. All right, negative t minus 5, they're just having a little bit of a, I was reading and writing at the same time. Okay, so we have negative t minus 5 times t plus 2. Okay, so it says explain and simplify. So now notice we have a t, but that's no problem. We can have any variable we want. There's all sorts of variables. There are conventions. If you do a lot of science, if you take a physics class, then t is very often used for time, right? In medical application, it'll probably be used for time, but it doesn't have to be, right? N is usually used for a number, right? There are different conventions, but when you're making one of these equations, you can use whatever variables you want. Okay, so they ask us to simplify this. So we're going to use FOIL, and we're going to multiply these out. Okay, so FOIL, we're going to do the first. So that's negative t times t. So we have a negative times a positive. The signs are different. The answer is going to be negative. And we have t times t, which is just t squared. Okay. So we've done the FOIL. Now we're going to do the outside. I'll change to blue. So we're going to do the negative t times plus 2. That's the outside. So a negative times a positive, answer is going to be negative. And I have t times 2, which is just 2t. Now, it's just, again, this is a style thing, but it's not really an optional style thing. We put the numerical constant in front of the variable. Okay. So that was our outside. Now inside is, and I'll use green here, -5 times positive t. So a negative times a positive, also going to be negative. And then 5 times t is just 5t. And then finally, switch to black, last, which is going to be -5 times positive 2. Negative times a positive, negative 5 times 2 is 10. So we've now expanded our two binomials using FOIL. But the next step is to combine like terms. You're going to notice that when you're doing this, there's a pattern to it, and that the two middle terms are the ones that have to be combined, usually. Okay, so I have a -2t minus 5t, -2 minus 5. If you look at a number line, it's going to be -7t minus 10. And there we go. Now, if you weren't sure you got that right, you can go to the back of the unit. The support questions, the answers to the support questions are there. Okay, so you can go and check that. Okay. Now, the next one I'm going to show you here is where'd it go? Oh, it's 2F. So it's part F. And the reason I want to show that to you, they don't really talk about this in the book. You're going to look at this and you're going to say, well, what is that? I'm supposed to be multiplying two binomials together, right? And this is one of those cases where once you see it, you'll laugh every time you see it again. What x times x minus 5 squared means is x minus 5 times x minus 5. So in other words, if I expand this out, x minus 5 times x minus 5, that's all a square means. Well, now you just use FOIL, right? You can just solve that with FOIL. Okay. So anyway, there's more to that one. Obviously, you got to expand that one out. I'm not going to expand that one out. Let's see. Okay. So let's take a look at question 3A, because now you've added something to the mix here. 3A. I'm going to actually, yeah, I think we're all right. What do we have? So 3A on near the top of page 16, it's 5 times 3y minus 2 times y plus 7. Oh boy. Well, this looks like a grade problem. So what we have to do is multiply two binomials together, right? And then we got to somehow also multiply 5. Let's say that you had a mathematical problem where you had 2 times 3 times 4. Okay? Now, you might know the answer to that. That would be, what, 24? 26? Something. 24, right? How would you solve 2 times 3 times 4? Well, you could do 2 times 3 is 6, and then 6 times 4 is 24. Right? That would work. Right? You could do 3 times 4 is 12, and then 2 times 12 is 24. You could even do 2 times 4. You could do 2 times 4 is 8, and 3 times 8 is 24. The point is that when you're multiplying things together, it doesn't matter what order you're doing it. It doesn't matter a bit. So when you look at 3A, and what we have is 5 times 3y minus 2 times y plus 7. So there are 3 things that are being multiplied together. Now, if you're listening in, you're not going to be able to see this, but the things that are being multiplied together is the 5, and then 3y minus 2 is another thing that's being multiplied together because it's a expression in brackets, a binomial, and then y plus 7 is the third thing that's being multiplied together. We can do it in any order we want. So, what order are we going to do things in? Well, it doesn't matter. I'm going to pick one, and you're welcome to pick whichever one you want. Just don't lose track of the one you're doing last. Okay. When you're doing FOIL, what tends to happen if you do the multiplication first, the numbers are going to start getting big. So because FOIL is a little more challenging, intellectually taxing, I'll do the FOIL first so that we're using smaller numbers. Then we'll multiply the result by 5. So I have to remember that I have a 5 and that everything that I do after that is in brackets. Okay, so now I'm going to do the FOIL. F-O-I-L. Okay, so 3y times y going to be 3y squared. Outside is going to be 3 times plus 7. It's going to be 3y times plus 7, so it's going to be positive. And then 3 times 7 is 21y. Okay, inside I have negative 2 times y. It's going to be negative 2y. And then last I have negative 2 times positive 7, which is negative 14. And everything was in brackets. Okay. So now what I'm looking at for an answer, for those of you that I can't follow, that aren't following along on the Smart Bridget, is I got 5 times and then some stuff in brackets. What I have in brackets is 3y squared plus 21y minus 2y minus 14. So on the next line, I'm going to write my 5 again. I'm going to open a bracket. I'm going to start combining like terms. Well, we know the drill by now. It's the two middle terms when we're doing this kind of expansion. If you're multiplying different types of equations together or expressions together, you might be combining like terms in other parts of it, but when you're multiplying two binomials together, it's always going to be the middle two. Okay. So I have 21y minus 2y. So 21 minus 2 should be plus 19y. If I wasn't sure, I'd grab my calculator and check. And then minus 14. There we go. Okay, so now we're getting down to the end here. I have 5, and then in brackets times 3y squared plus 19y minus 14. Well, now it's a matter of using the distributive property, and I'm going to multiply each term inside the brackets by 5. Okay. And I'm going to do that the same way we've been doing all along. First, I'm going to get the sign. So I have 5 times 3y squared. They're both positive. My answer is going to be positive. 5 times 3 is 15, and so my answer is 15y squared. Now I'm going to do the middle term, which is plus 19y. Again, they're both positive. Okay. And so it's going to be, I'm going to put a plus sign down here. And now I have 5 times 19, which is 95, and y, right? So it's actually 5 times 19y is 95y. Okay, and then the last one, I have 5 times negative 14. So it's positive 5 times negative 14. And my answer is going to be negative because the signs are different. The signs are different. The answer is always negative. And then I have 5 times 14. Okay, so I get out my my fingers and toes here, and I'll count that up, and I'm pretty sure that comes out to be 70. Now, when you're doing this type of distribution of a variable in front or a constant in front, or it could be a variable, it could be anything, then it doesn't, there's no combining like terms. But you double check anyway, look at it, make sure there's just one of each type of term. So our answer there then was 15y squared plus 95y minus 70. And I could look that up in the back and make sure I got it right. So you can look it up there if you'd like. So that was 3a, and then all the rest of them are similar. It does get complicated when you have something like b where there's a negative sign in front, but really you're just going to work out the signs the same way we did this time. You know, you have the negative sign. Okay. Okay, I think that's pretty much all of them. Okay. Now, you'll notice that our result here is not in a vertex form. Okay, it is a quadratic. It's a it is a parabola. Okay, this is definitely going to be a parabola. However, we don't have any. The only thing we can see is the a. We actually do have the a value, but this is something called standard form. when we were looking in in lesson 1, we were looking at vertex form, which actually had the coordinates of the vertex, the highest or lowest point in the parabola. But in standard form, that form is y equals ax squared plus bx plus c, and we really don't get any help for the shape of the parabola there. Okay, but there's a benefit to having standard form. There is a big benefit. And the big benefit is that it's relatively easy for us to find out where the parabola crosses the x-axis. All right. And to do that, we need to be able to factor the parabola. The standard form. Okay. Well, factoring. In other words, we need to be able to go from what we ended up with at the end of 3a back to the original. So we're going to learn how to undo what we just did. Okay. All right, let's take a look here. Let's see. Okay, some examples. Here we go. All right. Let's take a look at page 16 in your Unit 1 book here. Let's see if I can find. Okay, that was not page 16. I got to back up. Looks like there it is. So page 16, and what you're looking for is the section that says factoring quadratic relations of the form ax squared plus bx plus c, and put a big star beside this next little bit here, please, where a equals 1. Put a humongous star. Put 3 stars next to it. Put 3 stars and an arrow next to it. It's really important that you understand that what we're going to do here only works when the a value, when there's no constant in front of the x or the y or whatever the squared term is, right? In this case, the standard form shows ax squared. We basically don't want anything in front of the x. In other words, a is equal to 1 because we don't write the 1. Okay, now they show a list here in the example. It has y squared minus 8y minus plus 15. That means that our a value is 1. Okay, we just don't write 1y squared. It's just a waste of time to write that. We'd be writing 1s all over the place. Okay, and the second is x squared plus 3x minus 10. Again, our a value is 1. Now, it doesn't mean we can't use this technique when a is not 1. It's just that we have to make one more step. Okay, so let's then back up to the example I just showed. I just showed 2 examples. Okay, so example 2c, we ended up with a negative t squared minus 7t minus 10. Now notice we have negative t squared, which means that our a value is negative 1, meaning we can't use this technique. Right? We would have to do something to get rid of that negative 1. Similarly, in 3a, we ended up with 15y squared. So we also can't use that technique because we have a 15 there. Okay, but there is a fairly straightforward way of getting rid of that number in front of the variable, and you'll learn about that in the lesson. But I just want to make sure that you got that because, oops, all right, I'm going the wrong way here. So make sure you got that. So all we're talking about is when there's no number in front of the first term, the squared, x squared or y squared or whatever it is. Okay. So if you get one that has a number in front of it, you're going to have to make one extra step to get rid of that number. So when we're looking at example 1 here, let's take a look at example 1. It says factor y squared minus 8y plus 15. So we see here that there's nothing in front of the y. There's no negative sign. There's no number, meaning that a is equal to 1. So we can go ahead and factor it. Now, what we need to do here is look at the negative 8y and the plus 15. And we have to remember that when we're doing FOIL, how we end up with those numbers. Okay. We end up with the 15 if we have, in this case, it's y plus a and the y plus b, okay, our a and our b give us the 15, and they give us the -8. Okay. And the game that we play when we're factoring one of these expressions is to try and figure out what the a and the b value is. Okay. Basically, in our case, a times b is equal to 15. Okay. And a plus b has got to be equal to -8. Okay. And that's always going to be the case. So in other words, you're looking for two numbers that you multiply together to give you the constant term at the end of the expression, and that you add together to get the coefficient, the number in front of the variable in the middle term. That's fancy math talk for the number in front of the variable is called the coefficient. There you go. You'll be ready to have something to talk about at your next party, what you're learning in math. So when you multiply those numbers together, keep in mind that the signs of the numbers are also important. So in our case, it's positive 15, right? So what numbers can we multiply together to get 15? Okay, well, 1 and 15 can give us 15, but so could -1 and -15, right? That would also give us 15. What else can give us 15? 3 and 5, right? And of course, -3 and -5. Now, what most mathematicians will do is they'll kind of go through the list, maybe not write it out. Once you get some practice, you'll start to see how this goes. Because we also have to find these two numbers. It's not enough that they multiply together to give us 15. They also have to add to give us -8. Now, that's a clue, right? As soon as you see 3 and 5, and you realize that 3 and 5 added together are 8, you're almost certainly going to be dealing with 3 and 5. Now, whether it be +3 and +5 or -3 and -5, that's what you have to work out. Well, what's -3 minus 5? -3 minus 5 is equal to -8, isn't it? And -3 times -5 also is 15. So the ones I'm going to box in green are our two numbers, -3, -5. Okay. So now that we have those two numbers, it's a pretty straightforward step then to set up the two binomials that were used to generate the y squared minus 8y plus 15. If I say I'm going to put y in brackets, and now it's -3, -5. Okay, so it's y minus 3 times y minus 5. Okay, and if you were to work that out, you should end up with y squared minus 8y plus 15. Okay, if you think about it, if we go through FOIL, okay, I just wiped out my y. Y times y is y squared, of course. Outside is -5y, inside's -3y. -5 minus 3 is -8y. So that's our middle term. And then -3 times -5, which is our last, is indeed going to be plus 15, which is what we have. Okay, so that's how the factoring goes. Basically, you're going to look at the middle term and the last term in your standard form, and you're going to try to find two numbers that when multiplied together give you the constant, and when added together, including their signs, give you the middle term, the coefficient, the number in front of the middle variable. Okay, and once at first it might be a little awkward, but once you get used to this, you'll be able to reel these off pretty quickly. Okay, did I get it right? I hope I did. -3 minus 5. That's what I got, right? Yeah, indeed. Okay. I was worried there for a minute. Okay. All right. So now example 2, you can cover up the solution. We don't need the solution. We can do it. This is going to work. Okay, so we have plus 3x and we have -10. Remember the sign in front of it, it counts. So I need an a times a b that gives me -10. Okay, so now in order for it to be negative, the signs of the two numbers have to be different, right? So it could be 1 and -10, or it can be -1 and 10. Now, a lot of people who are, once you get used to this, you'll just put down one set of numbers and you'll understand that you don't have to, get the signs right away. But the problem with 1 and 10 is that no matter if I add them or subtract them, it doesn't give me 3. Right? So I'm going to need something else, something that has a difference of 3. So let's try 2 and 5. That works. 2 and 5. Okay, so it's either going to be -2 and 5 or +2 and -5. So let's see. It's a +3. So 2 minus 5 doesn't work, but -2 plus 5, indeed, that's the one, isn't it? -2 plus 5. So now that I have that, it's just my two binomials are x, and it doesn't matter which order we go, x plus 2 and x minus 5. You just write them out like that. I could put x minus 5, x plus 2, it doesn't matter. Okay. So if I work that out, what did I just do? I just, okay. Yeah, I hope you caught that. Yeah. I said that x minus 2 and then I proceeded to write down x plus 2. Okay. Now, why did I catch that? Okay, I caught it because I looked at it and I did the last step in our 4-step problem solving model, which is, does your answer make sense? So I quickly did, 2 minus 5. No, that's not it, is it? So let me fix that here. All right, and here's a nice thing about math. Okay, well, that's not the nice thing about math. If you're listening at home, I'm having problems with the whiteboard here. I don't know. X minus 2, x plus 5. There we go. Okay, and I just scratch it out. Okay. So the nice thing about math, you can always go back and fix stuff, and if you were organized and you write neatly enough, you can do what I just did. I don't even write neatly. I just scratched out some work and I put the right answer below. You can do that, right? If you send me a paper where you fixed a problem and you had to go back and you scratch stuff out, as long as I can read it and see your answer, it's fine. It doesn't have to be perfect. It doesn't have to be neat. It has to be logically correct, mathematically correct, and hopefully right. That's what we're going for here in math. Okay? So everything you do in math is a rough draft. Okay. So let's take a look at question 6. It says factor completely, and that's what they're talking about. So you're going to go through that, and oh, look at that. We got h here. Ooh, that looks evil, because you see you can't do h. Okay, you have to get rid of that 5 in front of the n squared. So that's page 17. Okay, so you'll have to do that. And I have about 5 minutes, and just really I'll be talking about this next time. But let's take a look real quick at what we can do. I got 5 minutes. I have 4 minutes. Okay, so that's I'm just going to make a blank page here. So you can only do the factoring trick if there's no number in front of the first variable. So this is support question 6. This is h, and it's 5n squared minus 25n minus 70. Okay. So the way that we can do this, those are n's, by the way. They don't look like n. They look like h's. Sorry. Anyway, they're n's. So the way we do this, remember that if we have an equation, what we do to one side of the equation, we can, if we do the same thing to both sides of the equation, then we can do the same thing to both sides of an equation, as long as we do the same thing to both sides. So what I really want to do is rewrite this so that there's a 5 out front, and then there's some stuff in the brackets. And I want to do that because I want to be able to get rid of this 5 here, right? I want to be able to get rid of the 5 in front of the n. Okay. So this is called factoring, and basically what we're going to do is we're going to divide all of our terms here by 5 on the left side. We're going to multiply the expression in the brackets by 5 on the right side, and basically this works out to be the same thing. Let me do this. Okay. So we're basically factoring out of 5. Let me write this again. I'm not really happy with the way I'm kind of showing this. Okay. Let me just show it this way. 5, and now I have to factor out of 5. Let's see if I can find this real quick. I'm running out of time here. 5n squared minus 25n minus 70. Okay, so what I've done is I've multiplied everything in brackets by 5, and I now have to divide everything inside the brackets. I basically have to distribute that 5 through. Now for the first one, we can cancel out the 5. For the second one, we just have to divide the 25 by 5, which gives us 5. And for the last one, we're going to divide the 70 by 5, which gives us oh boy. Yeah, 14, sorry. Right, which gives us 14. So now we can rewrite this as 5 times n squared minus 5n minus 14. You can factor this second part, right? Because now it's in the proper format, and then your answer will just be 5 times n, and then there'll be 2 n terms in there. Okay, we'll revisit this on Monday. And but that's just to get you going if you wanted to work on it over the weekend. Okay, I better get off the air now. And thanks for joining us. Remember, there's no class tomorrow, so we'll see you again on Monday. Bye now.